Midst again.
Yes.
So, ഇതിപ്പം മൂന്നാമത്തെ ദിവസമാണ് മിസ്സേ. സോ
Okay.
ഇപ്പം ഇതുവരെയുള്ള എല്ലാ ഇത് ടെസ്റ്റ് ടെക്നിക്കൽ സെഷൻസും പോലെ തന്നെ ദിസ് ഓൾസോ വുഡ് ബി ബെനിഫിഷ്യൽ ഫോർ ദ സ്റ്റുഡൻസ് ഫോർ ഷുവർ. സോ ഫ്രം ദ ബോട്ടം ഓഫ് ദ ഹാർട്ട് ഫോർ ദ ഡിപ്പാർട്ട്മെന്റ് ഐ വെൽക്കം യു മാം ടു അവർ സെഷൻ.
Thank you. Thank you very much. Shall we start the session now?
Yeah, 1 minute, ma'am.
Okay.
Sahim is?
Sir,
Yeah.
time is two, sir.
So, ma'am, shall we just wait for another 5 more minutes so that the other
ഒരു
papers
6
know?
minutes
Because
കൂടെ.
only just 9
Okay.
members are there. It will be
Okay.
almost above 40 normally. So, shall we just wait for another 5 more minutes, ma'am?
അതെ 154 അല്ലേ ആയിട്ടുള്ളൂ. We can wait.
Okay.
No
Okay.
issue.
Okay.
Good afternoon, everyone. I welcome you all to the second session of today's workshop on emerging trends in sustainable and resilient infrastructure 2023-24. The speaker of the day for the second section is Dr. Deebaji Nair for the technical topic on sustainable construction. Dr. Deebaji Nair is a professor in School of Engineering, Cochin University of Science and Technology. She has a teaching experience of 21 years and industrial experience of 4 years. She has done many publications and also have the membership on different professional bodies. So I welcome you, ma'am, for the technical talk. Over to you. Thank you.
Okay. Thank you very much. Am I audible?
Yes, ma'am.
Yeah, the screen also visible, full screen mode.
Yes.
Okay. Thank you very much. Good afternoon, everyone. Before starting the session, let me express my sincere gratitude to the organizers for giving me the opportunity to deliver the session in this workshop. So today we'll be discussing about sustainable construction. Actually, through this presentation, I would like to present the research findings of one of my doctoral students. He has just defended his thesis, part of his research work. So, modification on the definition of sustainable construction and on conceptual framework for sustainable construction. Actually, the first part of this, hope you are able to see this slide. Structure of the presentation is like this. First, I'll be discussing about conceptual framework for sustainable construction. So here we will be, I'll be giving you an explanation on what is the actual definition, what is meant by sustainable construction, and how to evaluate the construction practices to decide whether it is suitable for sustainable construction, and how it will be able to contribute towards sustainable development. That's the ultimate goal. So the first part of the presentation will be giving you an idea about details of sustainable construction and the tool for evaluating sustainability in construction. That's what is known as conceptual framework. Conceptualizing the idea, and then the framework is proposed. And the second part is actually an evaluation of the construction practices, what we are seeing in Kerala these days. It's not a complete evaluation, it's actually a partial evaluation based on qualitative analysis. And then the third part is dealing with alternative technological options. So here I'll be presenting one prefabricated construction. So this is all about the structure of the presentation. So we'll start with the first topic, conceptual framework. Before going to the details, we need to know why sustainability in construction is so much essential. We know the impacts of construction. Every activity is contributing towards resource exploitation, environmental pollution. Everyone is discussing about that. All of us are civil engineers. I'm not sure about the background, but I hope everyone is with a civil engineering background. Is it like that? All the audience?
Yes, ma'am. Yes, ma'am. But there are 2 or 3% participants who is from other branches also, ma'am. But
Okay.
majority is from civil engineering fraternity.
Okay. Anyway, it doesn't matter. This is not going to the details of any civil engineering technology or anything like that. It's somewhat, sustainability is generally an interdisciplinary topic. So everyone will be able to understand. Actually, in this presentation, we'll be conceptualizing it so it can be understandable to everyone. So before going to that details, we can talk about the impacts. We want to overcome these impacts. So these are the figures. Resource exploitation, 40 to 50 million metric tons of all these raw materials, crushed rock, sand, gravel, extracted from quarries every year. Half of it is consumed by construction industry. There we need to see the importance, how far the construction industry is utilizing the resources. When we take the case of India, that's a worldwide statistics. If we take the case of India, in India currently it is the detail from 2018 reference. Yeah, but we can still relate to that. In India, currently 0.7 million hectares of agricultural land is utilizing for brick kilns, thus distracting the suitability of topsoil for cultivation. Here in Kerala also we can see the things, how far, how extent, how the of the land was utilized for brick kilns, how it was affecting our climate, and we were able to notice the ill effects of all those things in the recent years also. And with regard to environmental pollution, embodied greenhouse gas emissions due to construction industry are approximately 5% to 10% of the entire energy consumption in developing countries, and 10% to 30% in, yeah, the first figure is with respect to developed countries and the second figure is with respect to developing countries. If we take the construction industry, we can see that cement is a mandatory material for construction. All the activities we need cement. How much quantity of energy is utilized for cement? All of us are aware about that. 1 kilogram of cement produces manufacture of cement produces 1 kilogram of carbon dioxide, almost equal. It's actually 0.9, but we can say that almost the same amount of carbon dioxide. So it is contributing to environmental pollution. And this is another figure. Building industry generates 35% of total greenhouse gas emissions and 33% of all. Between environment and development. Started with environment. Now also when I was discussing about construction, I was talking only about the environment. But later in 1987 Brundtland report, they defined sustainable development and identified the links between social, economic, and environmental dimensions. So, two more dimensions were added along with environment: social factors and economic factors. Later in Johannesburg summit, one more factor. There also they were talking about triple bottom line concept, 3P concept: people, planet, and prosperity. But after that, many of the researchers were working on this, and they have introduced the fourth P related to the project, that we can call as technology. So now, this was the concept earlier, 3P concept: environment, economy, and social aspects, but it is changed as 4P concept: people, socio-cultural aspect. Whatever technology or whatever development we are proposing, it should be for helping the people. So we need to think about their aspirations and their requirements, and accordingly only we need to propose something. Then only it can be sustainable. And we need to think about the environment, of course. Prosperity, how far it is economical, how far it is affordable, and definitely related to the project, there we need to think about the technology. So sustainable development is a 4P concept. It's actually a balance between the present needs and the future needs. Now we can see that the construction industry is how much influential in contributing to this objective. We need to know the importance of practices, construction practices, to make it sustainable for contributing towards this objective. Then we need to think about the sustainability in construction practices, how far it is possible. We'll see that. So what is sustainable building? If you are saying that sustainable development is a balance between the present needs and future needs, the same way we can connect sustainable buildings also as a balance between the present building needs. If you are proposing a building, it may be serving the needs of the people. So the same way, the resources, whatever we are utilizing, it should be there for the future generation. So what we need to do? Preserve the natural resources and ecosystem for future needs. without affecting the natural environment. So that's the concept behind sustainable buildings. But nowadays, all of us are talking about green buildings. Yeah, we'll come to that. So this also is a concept put forward by sustainable buildings. The same way, it's a you can see the tetrahedron here: people, planet, project, and profit. According to this proposal, what you consider as important, you can put as the apex of this tetrahedron. Like if you think we need to give more importance to planet, it can be on the apex. Here the importance is given for project. Then what will happen to the base points? They will have the same significance. So that also is another concept. But what about green buildings? Now everyone is thinking that green buildings are sustainable. Are they sustainable? In the case of green buildings, we are talking only about the environment. That's the reason it's not affordable to everyone. It's not that popular as we see other buildings. So, to make the green building sustainable, we need to include the other three P's also: project technological aspect, environmental economical aspects, and also, moreover, we need to consider the socio-cultural aspect, the people aspect. Green buildings are resource efficient construction for healthy living. This is the principle. Energy efficiency, all the resources. We have to optimize the resources. That way we'll be able to save the environment. Energy efficiency, water efficiency, material efficiency, and along with that, environmental quality is also protected. Improved air quality and less waste. All these will contribute towards healthy living. But in the case of green buildings, we are talking only about the environment. But we need to consider the three other P's also. How it is possible? We can do it through sustainable construction practices. So we'll discuss about that. Sustainable construction. Actually, this discussion on sustainable construction has happened very long back in 94. The first international conference on sustainable construction proposed the definition for sustainable construction as creating a healthy built environment using resource efficient and ecologically based principles. So here also we can see that connection with the sustainable development. In the initial stages of the discussion related to sustainable development, they were also focusing only on the environmental aspect. So here also the focus was initially given only on the environmental aspect. Later, like sustainable development, three pillar concept was introduced, and now recently technological innovations are found significant. Researchers are focusing more on the technological innovations to make it sustainable. We'll see that. So here we can see some tools for evaluation. Initially, I told you that I'll be presenting a tool to evaluate the sustainability of construction practices. So here in this research, actually, he was taking, one of my research student was working on that, discussing about different frameworks to evaluate the sustainability in construction practices. It started with 94 Kibert. According to him, that stage everyone was focusing only on environmental aspect. So his framework was also focusing on environmental sustainability. It was found very comprehensive, but only with respect to environmental sustainability. Focus on other aspects of sustainability were found missing. That was the issue. But later in 94, 97, environment, economy, social, and technological sustainability were introduced in the framework by Hill et al. Comprehensiveness was there in the planning stage. We all know if you want to do a construction, whether it is a infrastructure development activity or if it is the construction of a residential building, everything will be starting with the planning stage. So we have to think about the implementation of sustainability principles in all the stages of the construction. When we are planning the building, there itself we need to think about the sustainability, how we'll be able to implement the all these four concepts: technological aspects, environmental, economy, and socio-cultural aspects need to be continued. Planning, design, construction, operation, and later at the demolition stage, decommissioning stages of the project. But comprehensiveness was found missing in the implementation stage. That was an issue with this framework. Later in 2006, this is actually my own research during my PhD work. I was also working on this framework. So there I was connecting all these four aspects of sustainability, and one framework was put forward. But the issue related to that framework was equal significance was proposed for all the aspects of sustainability. That means, if you remember the previous figure related to sustainable buildings, I have shown you one picture of tetrahedron. So, what you consider as important, we need to consider as the apex point. In my conceptual framework, it was not like that. It was a circle, really interrelated circles, as we usually see the 3P concept of sustainable development. We see three circles connected together. This proposal was also similar to that, but instead of three circles, four circles were there. But the issue related to this framework is equal significance. It is an ideal situation only, it can never be possible. So, more flexibility is required in this concept. So, further modifications are required. So, accordingly, the new proposal is new research work has, as a continuation of this particular work, the new proposal has done, and I'll be presenting it now. Yeah, again in 2013 also, one more framework that found important. But there also significance was given only on three aspects. Systematic grouping of indicators and factors were found missing. So combining all these frameworks, after completing the review and evaluation of all these frameworks, the problems identified were like this: need for redefining the concept of sustainable construction. What is sustainable construction? It's not related to environment alone. How we will be able to include the other aspects of sustainability? And need for a holistic framework with respect to the objectives of sustainable construction, and need for the systematic identification of indicators, criteria, and also there should not be any duplication. If we are evaluating one criteria under a particular objective, we should not evaluate the same criteria under the other objective. Like I'll explain it. So this was the this is regarding that conceptual framework. Actually, publication is also there. So it's a 4P concept: people, planet, prosperity, and project. Project is related with the technology aspect. So the definition is like this: it is an approach or practice based on cradle to cradle concept. Earlier we were talking about cradle to grave concept. Cradle to cradle concept is we are utilizing the material again and again. We are not going to dispose it off. If you are disposing it in the environment, means it will again contribute to pollution. But if you are able to reuse it, means it will add to resource efficiency. So this is one important point, cradle to cradle concept, which is socially acceptable. That is the people aspect. Economically affordable, that's the prosperity aspect, profit economy aspect. Technologically reliable, project aspect. And environment friendly, contributing towards sustainable development. So as you see in this figure, the objective is sustainable construction and sub-objectives are socio-cultural sustainability, economic sustainability, technological sustainability, and environmental sustainability. So we'll define one by one. If you want to propose a particular construction practice as sustainable, it need to fulfill the objectives of fulfill all these four sub objectives. How can we fulfill all those sub objectives? We need to know the criteria for fulfilling it. So we'll discuss one by one. Socio-cultural sustainability is actually related with people. If I am proposing a new technology, it is for the people, so they need to accept it. How can I accept a new innovation? I need to know about the technology. So based on the popularity, and also it should suit to my needs. There should be enough flexibility to suit the requirements of the stakeholders. And also enough resources are available. So the definition is like this. Socio-cultural sustainability in construction can be defined as the popularity of technological option and their flexibility to suit the requirements of stakeholders with respect to resource availability and limitations. That means we can evaluate the socio-cultural sustainability of a particular technological option with respect to the popularity of technological option. How you will be able to evaluate the popularity of technological option and flexibility of technological option? For that, different indicators are also put forward. These indicators are community participation. If you are proposing a particular technology and community participation is possible, that means no skill labor is required for that. Everyone can participate in that. Definitely, the popularity will be more. And if there are some social cost or benefit is embedded in that particular option, everyone will go and approach it. And also awareness. We need to have the awareness about the technology, adaptability to suit the requirements, satisfaction. So we'll see one by one how each of it can be evaluated. Community participation using the local resources, unskilled labor, and local infrastructure. It can assure community participation. Maybe, for example, if I'll say about our concrete block masonry, no skilled labor is required for the manufacture of concrete blocks. We can see that many small scale industries around us. Community participation is possible. If you are able to show, explain the procedure, anyone can make. You have the machinery with you, you will be able to manufacture it. And also, if you think about mud construction, local resources are available. Adobe mud blocks. It can be made in our own houses. So local resources are utilized. Unskilled labor is also there. We can utilize it. So this is only one factor. You may be thinking that why mud construction is not that popular. This is only one aspect. Community participation is possible. But what are the other issues with mud construction? We need to think about that. Then what is the social cost and benefit? We can usually see that if some innovative technologies we are proposing and saying that they are green technologies, like solar panels were introduced, and then government is giving some subsidies and all those things, definitely we will go and adopt it. So they are the additional benefits we can get by adopting this technology. So this is also a technique for popularizing an innovative technology to provide this social. And if you are able to see that there are some social benefits, that also will help you in popularizing the technology. Awareness, this is an important aspect related to socio-cultural sustainability. It can be measured in terms of two types: practical awareness and knowledge based awareness. What is practical awareness? Usually, we see that many of the technological options, I can tell you the example of filler slab. Filler slab was introduced by Laurie Baker in 1980s. Later, we were able to see in many of the constructions, cost-effective and environment-friendly construction, filler slab was used. But nowadays, we are not able to see any of the present construction practices or buildings utilizing this filler slab technology. Only those buildings, they are there from 1980s or 1990s, maybe in the beginning of 2000, are only there. No more new buildings are there. What is the reason? Practical awareness. If you see a particular technology, you need to develop the practical awareness, and you also need to develop the knowledge based awareness. Only by seeing this technology, if you are going to implement it, only by practically knowing about the technology, you are going to implement it. It can lead to the failure of the technology. So both the things are important in popularizing the technology. If we take the case of filler slab, we can see many advantages. Environment friendly, and also technologically it is durable and strong like any other RCC slab. But still cost effective, 30% of the cost can be reduced. What can be the reason for the failure? And also adaptability, flexibility, and feasibility according to the changing needs of the users with respect to site conditions, style, and harmony with culture. If you are proposing a particular technology and saying that, yeah, this is innovative, you can adopt it, you can consider it as a sustainable technology, but that particular technology is not adaptable to the site conditions. Maybe I can tell you the example of maybe prefabricated construction. We need heavy machineries. So what will be the case if you are going to adopt this prefabricated construction in hilly areas? There it will be difficult. So according to the site conditions, and also prefabricated construction, if you are the plan may be given, and according to the plan different wall panels are made, roof panels are made, then it will be difficult for changing the style. So that case also there will be a problem. So adaptability is limited. And we also need to think about harmony with culture, tradition, whether this particular technology is proposing. It is in line with the harmony and culture of the people, of the stakeholders. So that there are different criteria to evaluate this. And the next thing is satisfaction. What we usually call as satisfaction. It is decided by, it can be evaluated by the satisfaction of all stakeholders with regard to trustworthiness, attitude, comfort, and security based on their personal preferences. So here also we can do the evaluation based on the personal preferences of the stakeholders. all the indicators coming under the socio-cultural sustainability, since it is related with people, it will be varying. Only qualitative evaluation is possible. If I am saying that, oh, this is suitable to my comfort, it may not be I'll be satisfied, I can be satisfied with this particular technology. But some other person may be having a different comfort. He may be saying that it's not good for them. Accordingly, it will vary. Trustworthiness is also important. Reliability. Otherwise, if we are proposing a technology and saying that it is cost effective, you can reduce the cost, like the case of filler slab and cost effective environment construction techniques, 30% of the cost can be reduced. But people lose the reliability of the technology due to the failure of the construction. And attitude, that also is very important. If you think about with the same example, I can tell you regarding this criteria. If we see those buildings with exposed brickwork, what we usually call those buildings, instead of, I will every time say it as cost effective construction, but most of the people will be referring it as low cost construction. So what about the attitude? That also will affect the satisfaction. So all these aspects are, all these criteria, all these indicators are related to people aspect. Security and safety, that also very important. And comfort, there are many criteria for comfort, like age group comfort, thermal comfort, visual comfort, acoustic comfort, privacy, all those things. Different age group people, that we can maybe certain type of flooring, aesthetically very good, so visual comfort is there. Cost is also less, but it is too slippery. Whether we'll be able to adopt it, we have to consider many factors. So socio-cultural sustainability, if we group all those things, what we have discussed so far, we can see that socio-cultural sustainability is an objective of sustainable construction, is a sub-objective of sustainable construction. As we see here, this is the objective, sustainable construction. It is a cradle-to-cradle concept. To achieve the sustainability in construction, we have to fulfill the objectives under all these four aspects. So for measuring socio-cultural sustainability, the indicators identified are community participation, awareness, adaptability, satisfaction, and each of it can be measured with respect to the criteria and sub-criteria as shown in the figure. Now we'll discuss about the second aspect, economic sustainability or affordability. Usually the synonym is affordability. Whatever we are proposing, it should be affordable to the people. It should be affordable to the stakeholders. Otherwise, like the example of solar panels, we can say that environmentally energy efficient, environmental sustainability is there. We can reduce the cost. We can reduce the usage of energy from conventional sources if you are utilizing the solar panels. But how far we will be able to, how many people can implement this technology in their houses? How long we need to wait for getting back the money? So that way it will affect the sustainability. So what are the things we need to consider under economic sustainability? Usually, with respect to construction, these are the indicators identified: process duration, life cycle cost, and feasibility of resources. Process duration, all of us know the importance of the duration. If you are implementing a particular activity, construction, time is very important. Time and cost performance are interlinked. Yes. Any of you have anything to say? So this also I can tell you, if you are comparing two types of technology, maybe mud construction and concrete, you know that this is very important. Process duration, it will take a long time for getting the required strength. But for construction, but for concrete, we know the required time is far less. And life cycle cost, feasibility of resources, life cycle cost, there also many criteria are there, like initial cost, cost in use, environmental cost, residual value. All these will contribute towards the economic sustainability. If you are proposing a technology and saying that the initial cost is less, but we have to think about how much cost, what is the cost in use, whether the total cost of this particular technology will be affecting the sustainability aspect, whether there is any hidden environmental cost, and what will be the residual value. All those things will contribute to economic sustainability. And feasibility of resources is also very important. We can propose, we may be having many innovative options around us in construction, but some of the options, if we check the feasibility of resources, material availability, usually we see that these materials can be utilized as cement replacement, but are they available locally? Is the technology available? Technology may be available, but infrastructure feasibility is not there. So that is also another important factor. To popularize the technology. Actually, all these things are related with the economical aspect. Popularizing the technology is related with the socio-cultural aspect, but economy aspect, the infrastructural feasibility and labor accessibility. This was also an important aspect related with the Ratrabone construction. Hope many of you are aware about this Ratrabone construction introduced in SIF technology. I'll come to that. I'll show the picture. Ratrabone construction was an alternative type of masonry, a cavity wall construction. Cost was also less, thermal comfort was also there, environment friendliness was also there, but labor availability was limited. So that way, the cost went high. So feasibility of resources is also very important in deciding the affordability of a technological option. So these are the criteria, these are the indicators under economic sustainability: life cycle cost. One moment. Under economic sustainability, indicators are life cycle cost, feasibility of resources, and process duration. To measure those indicators, different criteria is also proposed. Now, we'll come to this technological aspect. All of us are very much aware about the technological aspect. Basic aspects are strength and durability. Depending upon the options, the criteria will vary. If it is a building block, what are the requirements of strength and what are the requirements of durability, weathering resistance, we have to measure accordingly. So according to the technological option, quantitative evaluation can be done on technological sustainability. That's what presently we are doing. If you are proposing a technology, basically in the lab, we will do the technological evaluation only. We won't consider, we may be considering the initial cost based on the experiment, small scale experiment. We may be comparing it. But mainly as technologists, we will be evaluating this part. Now, what about this environmental sustainability? This is the major aspect. As we discussed in the beginning, impacts of construction are basically on environmental quality and resource depletion. So the objectives need to address these two aspects. How the environmental quality can be maintained, how the resources can be protected. So environmental sustainability in construction takes care the protection of natural environment with respect to the needs of the present and future generations. So how can we measure these indicators? Environmental quality, disturbances in ecobalance, land degradation, air pollution, and energy consumption are the main concerns due to construction and related activities. We need to maintain a healthy living environment. So, what are the criteria? We need air quality, we need water quality, we need noise quality, we need quality waste. So, if you are proposing a technology, you need to take care of all these aspects. What about the air quality? You just think about the construction site, how much dust is available. Water quality, how far it is affected. During the construction, before the construction, collection of raw materials. And with respect to noise quality, how far it is disturbing the local environment based on noises. Quarry sites you can think about. Quality waste. Quality waste is another important aspect. During the construction and before raw material collection, processing of the materials, every time we will get the waste materials. But are we able to utilize this waste? So that way also we can compare the technology. For this particular technology, this much waste is produced and 90% of it can be utilized. That means only 10% is disposed to the environment. Environmental quality is not that affected. So that way we can calculate the quantity of quality waste in contributing towards environmental quality. Resource efficiency, material efficiency, water efficiency, energy efficiency, land adequacy, that also is a resource. It implies the efficient use of resources in sustainable construction with minimal environmental impact. Material efficiency, we can take the example of cement, highly resource intensive material. Highly resource intensive in the sense energy, high amount of energy is required, raw materials are required in large quantity, and it is disturbing the natural environment. So, cement manufacture is highly affecting the quality of the environment and disturbing the ecosystem, natural ecosystem. So material efficiency, it can be measured in terms of material adequacy and quantity of utilization of local materials. If you think about a particular construction activity, for example, we are going to construct a wall, a residential building. a wall construction is going on. We can think about the utilization of local materials, either mud construction, or you can think about any other material, locally available material. If you think about concrete blocks, they are locally made, means that also will contribute to material efficiency. Then what about this material adequacy? Usually for each of the construction aspects like wall, roof, plastering, flooring, we know the specific standards. Load bearing masonry, what is the minimum standard required for load bearing building blocks? Concrete blocks, usually it is 4.5 Newton per millimeter square. And non-load bearing blocks, like what we see in frame construction, we use non-load bearing. There the requirement is 2.5 Newton per millimeter square. We need to focus on the strength of these blocks. But in the case of concrete blocks, here the problem is we are not able to assure the quality of the blocks available. But what I want to say is that material adequacy, we just need to focus on the required strength. Like 4.5 Newton per millimeter square strength is only required, means we don't need to go for 7 Newton per millimeter square. Locally available concrete blocks are not like that. They are very inferior type. So maybe of the strength of 2 Newton per millimeter square. That's another story. But here in material efficiency, we are focusing on those technology with adequate strength. That means, yeah, maybe we can take the example of mortar, cement mortar. Cement mortar, usually the strength required is only 5 Newton per millimeter square, maximum. But what is the strength of the mortar we usually use? 1:5 mortar, 1:3 mortar. The strength is very high, 70 Newton per millimeter square. 1:3 mortar, usually the strength for calculating the cement compressive strength, we take 1:3. 53 Newton per millimeter square. But 1:3 usually we won't use for masonry mortar. Masonry mortar we usually take 1:5 or 1:6. But there also the strength is around 20 Newton per millimeter square, 25 Newton per millimeter square. We don't need that strength. We can reduce the quantity of the materials either by using cement replacement materials in that case. So this is only an example. So whatever technology we are adopting, we need to focus on material efficiency and use of local materials. Local materials can be renewable materials, reusable materials, recyclable materials, and waste materials. So these are the sub-criteria, and accordingly we can measure the material efficiency. In energy efficiency, this is very important with respect to embodied energy and operational energy. Embodied energy is an important term. Hope all of you are aware about that. Energy embedded in a material. It's the sum of the energy required for acquiring the raw materials, transporting it to the site, then manufacturing of the material. You just think about blocks, brick. First, we need raw material. We'll be transporting it to the factory, and then we'll be manufacturing the bricks. There we need energy. Then transporting to our site of construction. For that transportation also we need energy. So embodied energy is the sum of all these energy components. It will be different in different places. So how can we reduce this embodied energy? If you are using locally available materials, naturally available materials, especially waste materials, no energy component is there. Embedded energy will be zero in that case. Now we take the case of construction is done. So if we need any energy for operating it, that also will contribute to the total energy. So both of these are very important, embedded energy and operational energy. So this case, if we think about mud construction, usually we'll say that energy efficient, example for energy efficient construction. Embedded energy can be zero if you are utilizing the local mud. And operational energy, thermal comfort is there. So we don't require any additional cooling environment. So that can be less. So energy can always be minimized by the utilization of local materials with zero embedded energy. So this is the tree for environmental sustainability, only two indicators, environmental quality, resource efficiency. So under these indicators, we have many criteria and sub-criteria. This way, we'll be able to evaluate the environmental sustainability of technological options. So if we combine all these things together, this is the proposed conceptual framework for sustainable construction. Now you may be thinking that how we will be able to use this tool. Actually, this work need to be extended further for making it as a complete tool. So everyone will be able, when we are giving the values, we should be able to get the results. But now it is not possible. It's only in the form of a conceptual framework. We need to make it as a perfect tool. So these are the implementation guidelines. As we said, in the case of socio-cultural sustainability, it is highly dependent on the variations in the preferences of individuals and changing requirements of circumstances. Hence, qualitative evaluation after implementation of the technology can be recommended. How can we do the qualitative evaluation? We need to do the questionnaire surveys. If you want to compare some alternative technological option to check the sustainability of those options based on socio-cultural, for evaluating socio-cultural sustainability, we need to go for questionnaire surveys. Technological sustainability, we know quantitative evaluation. We'll get the results from the experiments. What about the strength? What are the standard specifications for durability? Are these options meeting those requirements? So that case, quantitative evaluation is possible. In economic and environmental sustainability, it needs a mixed approach, partially qualitative and partially quantitative. So there also, if you want to use this conceptual framework, it is little bit lengthy process. We have to do the questionnaire surveys and also we need to do the quantitative evaluation. So this way we have to give different points. It is an additive weighting technique. Simple additive weighting technique can be recommended for evaluating the sustainability index. I'll show you one example. This is an example for the evaluation of technological sustainability. Because only quantitative evaluation is required, we know how to calculate the, these are different options for building blocks. Building blocks in the sense, concrete blocks with different replacements of fine aggregates utilizing different type of base materials. Like if you see FB, fly ash blocks, quarry waste as fine aggregate, MB, manufactured sand as fine aggregate, laterite waste as fine aggregate, JB is Jarofix as fine aggregate. SB is our river sand as fine aggregate. So accordingly, these blocks were made and then the evaluation was done on the basis of technological sustainability, not on the basis of other aspects. This is only on the basis of technological. Usually for building blocks, we'll know the strength. So these are the variations, compressive strength, maximum value for JB means gyrofix blocks. So we'll take it as 1. maximum is taken as 1, and accordingly the scores are normalized and weight is also given, and we can calculate it. And then uh, other aspects are also considered: durability, water absorption, initial rate of absorption, and exposure to chemical environment, acid resistance, and alkali resistance. So there also the values are evaluated based on the experiments, and normalized scores are calculated, and at the end values multiplied by normalized scores calculating and comparing. This way we will be able to compare the technology based on each of the sustainability aspects. This is only an example of technological sustainability. If you want to evaluate socio-cultural sustainability, we have to go for questionnaire surveys. For example, if I tell you what is the acceptance of what can be the comparison between concrete blocks, bricks, maybe in mud blocks, laterite blocks, many other options are there. We need to go for questionnaire surveys, and we have to frame the questions based on the indicators and criteria. Accordingly, we can evaluate it, and based on that, we can calculate the scores. And at the end, after evaluating all the four aspects of sustainability, we will be able to calculate the cumulative index, sustainability index. Hope it is clear. Now we'll move to the second part. If there is any comments or any doubts or anything like that, we will discuss it later after completing this. So these are the specific features of this framework. This framework can be proposed as a universal tool for the selection and evaluation of construction practices. If you want to select a particular technology, then also you can compare it. And if you want to evaluate some technological option, it is already implemented. You want to compare it. So there also this technology, this proposal, this framework can be adopted. And also systematic grouping of indicators, eliminating duplication, overlap, and misplacement. This is an advantage of this framework. We can consider it as a holistic framework. Now we'll see a qualitative evaluation, not that comprehensive, a very qualitative evaluation of the construction practices in Kerala based on the sustainability without doing any what you call this questionnaire survey and all. Some we'll see the evaluation of sustainability practices in Kerala. This is our traditional construction. I don't need to explain this much. This was our traditional building. Stonework was restricted in the plinth, and laterite was used for the walls, or sometimes wooden walls were used. Roof structure in timber frame was covered with palm or coconut leaf, thatching or tiles. This was our traditional construction. And you know what is our conventional construction, present construction. I don't have the picture because every day we are seeing such construction. But this one, cost effective and environment friendly technology, it was implemented during the early years of 1980s to solve the housing problem in Kerala. SIF technology introduced by Lori Becker. Now we have many of the organizations like COSFORD, Habitat, Nirmiti Kendra, all of them were actively working on this. But now this type of construction is very less. Thought of just evaluating it, what can be the problem, why this technology is having many advantages, what is the reason for the failure of this technology, why people are reluctant to take this technology. In that background, an evaluation was done. So I'll just give you an idea what is a SIF technology to those students, they are not aware about this. SIF technology buildings, those buildings are characterized by brick masonry walls without plastering, exposed brickwork, with rat trap bond or Flemish bond, filler slab roofing, precast lintels, brick arches, corbelling. These are the common features. Natural ventilation in rooms facilitated through artistically designed honeycomb brickwork. So these are the characteristics of SIP technology buildings. Like this picture, you can see that arches are there, filler slab is there. Filler slab means MB tiles are using as the filler material, and exposed brickwork. And here we can see that it is Flemish bond technology. Usually in plastered walls we go for English bond masonry, but here it is either Flemish bond or rat trap bond. But this wall we can see it as a Flemish bond masonry, and this is what is known as corbelling. And this natural ventilation is facilitated through all these openings. So these are the advantages. Now we can do a comparison. Economy and environment, those are the advantages of SIP technology option. We'll consider that technologically both are same. Technologically both are comparable. So we'll just compare this with respect to economy, environment, and also social aspects. So conventionally, if you're going for foundation, we won't be able to suggest a particular foundation because that depends upon the type of soil. Usually, conventionally, we go for underable masonry in cement mortar, or we can also go for laterite or brick masonry in cement mortar. Sometimes RCC work, piling, deep foundation is required. That case, we need to go for that. But in sieve technology, renderable masonry in cement mortar can be sometimes replaced by mud mortar or dry packing depending upon the type of soil. Combination mortar can also be used. In the case of deep foundation, we can go for ground improvement techniques. Sand piling, bamboo piling, brick arch foundation, stuff foundation. And in the case of walls, conventionally we go for stones, burnt clay bricks, concrete building blocks, laterite. Sieve technology, there are many options. But how far we are using this? How far it is popular? Stabilized mud blocks, interlocking blocks, stone masonry blocks, lato blocks. And now we take the masonry, as I told earlier, English bond with cement plastering is the conventional method. Sieve technology, Flemish bond with cement pointing or rat trap bond with cement pointing. This is the case of rat trap bond. Cavity wall construction. Bricks are placed on edges. Usually we'll keep the brick flat, but here the bricks are kept on edges. So we'll have a cavity in between. What is the advantage? It will increase the thermal comfort inside the building, and also the number of brick bats are less. No brick bats are used. Quantity of waste brick can be reduced. This is the construction of rat trap bond masonry. And if you see the case of lintel or beam over the opening, conventionally we go for RCC lintels. Traditional buildings, we can see very natural lintels, stone, wooden lintels. In sieve technology, mainly the arches. Aesthetic appearance of the brick building is good. Precast lintels also can be proposed. Sometimes brick wooden lintels. Yeah, some pictures of arches, different type of arches. This is just bricks are kept on edges for maximum opening up to 1 meter. Segmental arch, pointed arch, semicircular arch, different type of arches. It will improve the aesthetic appearance. This is a corbelled arch, keeping the brick one above the other with a maximum projection of 1/4 of the length of the brick. This way, if you are extending, spanning over the opening, it will be like this. So this is a corbelled arch. Openings, natural ventilation. Traditionally, conventionally, we go for windows. But what about safe technology option? Honeycomb brickwork, jolly work, sometimes pivoted windows are also there. I'm not sure about the picture. Yeah. Pivoted windows can also be provided. Natural ventilation through these openings. Can see this bigger auditorium there also. And this is the picture of laterite filler slabs. Natural ventilation through honeycomb brickwork, jolly work. Again, how this is a picture of a residential building. Natural ventilation is facilitated. We can see that. We go for roofing. Traditionally, conventionally, thatch roofing over wooden trusses, clay tiles over wooden trusses, RCC roofing. But safe technology, filler slab roofing, shell roofing, precast brick paneling, LPAN roofing, different options are there. But how many of us are aware about all these things? Even becoming the civil engineers, we are not able to utilize it in our own construction. What can be the reason? This is filler slab construction. What is the principle of filler slab? Below the neutral axis, actually concrete is not required. Steel will take the tensile stresses. So that place can be replaced with any filler material. So here actually the filler material commonly used is Mangalore pattern roofing tiles. It is kept in such a way that one the upper one will be placed in the normal way, bottom one will be placed in the reverse direction, so that there will be an opening, there will be a cavity in between. That also will help in improving the thermal comfort inside the building. So you can see this section. Yeah, this is a picture of concreting work of filler slab. SIF technology was used earlier in public buildings. Here in Cochin University also we were having two buildings using it as Aditi Bhavan buildings earlier. And later one of the building was converted into engineering office building. So they plastered it. So that also is an issue. People, they are not this type of construction is not that acceptable to them. What is the reason? The other building is there in the campus, but no proper maintenance is done. Without proper maintenance, it will affect the structure. So such issues can be seen. Yeah, this is our building in Cochin University. This building is used, actually two such buildings were there earlier, but both the buildings are there now, but one building is kept like this, the other building is completely plastered. So this appearance is not there. This is another building, Panchayat office building. I think it is, yeah, some block Panchayat building in Ernakulam. And safe technology was popularly used in mass housing. So after doing this evaluation analysis, we came to this conclusion. Among the present technologies, traditional building technology is found to be more sustainable option over safe technology. Traditional building technology is found to be the sustainable option. Traditional technology, conventional technology, and safe technology. Are we able to go back to those traditional technology to say it as sustainable? There are many other issues, but what are the reasons for this? Overlooking of socio-cultural sustainability is the reason for failure of safe technology options in Kerala. That means the objectives under socio-cultural sustainability was not met. Technologically, it was good. Economically, it was affordable. Environmental sustainability was better. But what happened with respect to socio-cultural sustainability? What were the things we need to take care of? All these aspects, community participation, awareness was not there. Adaptability, satisfaction. Government was giving some benefits to those people they were implementing this type, but it was not enough with respect to all these aspects. People were not aware about the technology. Without having proper knowledge based awareness, this technology was implemented and the technology failure happened. Yes. We'll go to the third part. I think we have some 20 minutes more. We'll go to the third part. This is an option uh, from an alternative technological option for sustainable housing. Actually, I should not say sustainable housing, maybe a green building or something like that, because other aspects we need to check. So, utilization of a waste material for prefabricated construction. You may be aware about that FRBL panels or GFRG wall panels, glass fiber reinforced gypsum wall panels. It was utilizing the waste material from our FACT. So this is the first building. It was in 2008, FRBL wall panels. They called it as rapid house because they were requiring only 21 days for the completion of nearly 2000 square feet building. Walls, roofing, everything was made of this FRBL panels. So I'll go through this slides very first. So this is the picture of this wall panels with cavity, space in between. So this is the process. Phosphogypsum after calcination, rapid wall production, glass fiber and water additives were added, then drying it up and cutting the panels and then dispatching it. This is the manufacturing process. If you are able to give the plan of your building, they will be able to make different wall panels. Even the same panel can be used as the roofing. So these are different stages of the construction. Plinth foundation can be laid in the normal way as we do for other buildings. After checking the bearing capacity of the soil, we can decide the foundation. Then plinth beam reinforcements, startup rods are driven. Wall panels with door frame cutting and lifting the panel from the container. This was an disadvantage. We need heavy machinery for lifting it up and positioning the walls on the foundation, and then in between some columns through this for if there are any joints to connect the other wall, we can fill up this cavity because already the reinforcement is there near the joints. The reinforcements, it will act as a column with lean concrete. It will act as the column, fixing the ground floor panels. And these corner joints are also laid like this, T joints. So this picture shows the details of different joints. If there is a T joint, if there is a cross joint, then L joint, and likewise we can provide the reinforcements. M20 concrete is laid. Door fixing, positioning of the ground floor roof panels. Then after placing these roof panels, if you want to connect two panels, the cavity was broken and then a micro beams were laid for the roof like this. This way we can connect two roof panels and different sections for construction methodology, typical roof floor slab pattern. And over this, again, a 60 millimeter, 6 centimeter concreting was done. Concreting for the first floor, 6 centimeter. And then positioning of the first floor wall panels. Plumbing was also done. Painting. Yeah, in 23 days, not 21 days, it's a 23 days. So this was the initial picture. Then they thought of giving an additional roof to transform it to a Kerala style construction. So what are the advantages? Yeah, these are the details. 1,500 square feet. Basement, conventional rubble masonry with plinth beam, foundation and basement, walls, gypsum load bearing panels, roof also the same, doors and windows conventional timber type, flooring with refined tiles, plumbing, wiring, wall finishing. Advantages were the speedy construction, reduction in cost, minimum use of cement, steel, sand, earthquake resistant, eco-friendly, better insulation. We won't be able to call it as sustainable, we can call it as green building. It's an example of green technology. Yeah, if you think about the construction of a small residential building with 6 panels of required size, four for 4 walls and 2 pieces for slope roof, a small house can be built by the self-help within a few days. For mass housing, we can think about this technology to reduce the cost of construction. But how far it is sustainable, we need to evaluate other aspects of sustainability also. So this is an example of a green construction, I would say. So we'll come to the conclusion. So what we discussed so far, we started with the discussion of sustainable construction, conceptualizing it. So there the conclusion is 4 aspects are there of sustainability: people, planet, prosperity, and project. So sustainability of innovative construction practices can only be ensured with meeting the objectives of all these 4 aspects. We won't be able to leave any of these aspects. We have to ensure all these aspects. Significance of each of the objectives can be decided based on the demand of situations without overlooking of the other objectives of sustainable construction. Sorry, one moment. Yes, thank you. Any questions? Any clarifications? Yes. Can
Madam,
you? Yeah. Yes.
clear. Madam, is there any there is steps that has been taken up to include these things in the codes that we follow for our construction works now?
Means the sustainability aspects.
Sustainability aspects with respect to performance level only they have included in the
Yeah.
codes.
Yes. It's not
So
at, no, not yet included.
that what could be the step forward for this? Like in any of the forums should
Yeah,
be.
that's what we were also thinking about that. Now, if we think about green building rating systems, we have many rating systems like Griha,
Yeah.
IGBC, and all those things. It's for the building. The same way, we have to actually the next stage of this work is that only. We are under that work. We have to develop it as a rating system so that we can directly give it to some construction real estate developers. They can directly get some rating, and that would be helpful.
വലിയ
For,
അത്യാവശ്യം തന്നെ നമുക്കറിയത്തില്ലേ
yes.
എവർക്കൊക്കെ അല്ല ഒരാളെ ബുദ്ധിമുട്ടിക്കാൻ എവർക്കൊന്നും ഒരു ഉളുപ്പില്ല കേട്ടാ അങ്ങനെ ഉളുപ്പില്ല
I think there are some noise.
നമുക്കൊന്നും ഒരിക്കലും അങ്ങനെ പെരുമാറാനൊക്കെ നമ്മള് അതിന് വേണ്ടത് വെക്കാം പിന്നെ ഇല്ലാണ്ട് ബാക്കി
Maybe you
ഇത്രയും
can
പേര്
mute
മെനക്കെട്ട്
your mic.
അവൾ അത്രയും നേരം എന്തോ ആയിരുന്നു ചെയ്തോണ്ടിരുന്നത് ഇപ്പൊ ഹോസ് ഫയൽ അല്ലാതെ വേറെ എന്തെങ്കിലും പണിയുണ്ടോ ഇനി വേറെ ഒരെണ്ണം മാഗി പിള്ളേരെ കണ്ടുടനെ അവിടെ അത് ആദർശൊക്കെ വന്നതുകൊണ്ടാണ് പിന്നെ ഉടനെ അവിടെ പതുക്കെ അവിടെ ചപ്പി അടിച്ച് അവിടെ ഇരിക്കുന്നത് പൊക്കമുള്ളവൻ.
Yeah, I think maybe some problem. They need to mute their mic.
നീറ്റാണ് കേട്ടോ അവൻ. ഒലിപ്പിക്കാൻ അവസരം കൊടുത്താൽ ഒലിപ്പിച്ചോണ്ടിരിക്കും. അവിടെ ഇരുന്നതാണ് സാരംഗ്. അശ്വതി കണ്ടായിരുന്നു രണ്ട് പെമ്പിള്ളേരാണ്. അവനെ പോലെയുള്ള പയ്യനെയാണ് അവൾ ആഗ്രഹിക്കുന്നത്. മിസ് അത് അറിഞ്ഞില്ല. സ്റ്റുഡന്റിനെ കണ്ടിട്ട് കൊതിക്കുന്ന അവരുടെ ഒരു മെച്ചൂരിറ്റി ലെവൽ മിസ് ഒന്ന് ആലോചിച്ച് നോക്കിയേ. സാരംഗ് നല്ല പയ്യനാണ്. പയ്യനൊക്കെ അനന്യ കേക്കണ്ടേ, എവളെ എടുത്തിട്ട് ഒപ്പിച്ചോ. അവളും നല്ല കൊച്ചു.
Vasudev sir, maybe you can mute them. I think they are not aware their mic is unmuted.
മാം ഒന്നുകൂടി ഒന്ന് എക്സ്പ്ലെയിൻ ചെയ്യാം മിസ്സേ, എന്താ ഉദ്ദേശിച്ചതെന്ന് എനിക്കൊന്ന് ക്ലാരിഫൈ ചെയ്യില്ല മിസ്സേ.
Okay. Actually, green building rating system, if you want to rate a building based on this, they have many criteria. Likewise, here also we are proposing only the criteria. We have to make it as a tool, means then only we can implement it, propose it somewhere and implement it. But now it's
Okay.
under process.
Okay.
Now,
Now, ma'am was saying about something. Is that what she was trying to convey? Sanobia BS.
ഇന്റലിജന്റ് ഐറ്റം വല്ലതും ആണെങ്കിൽ തീർന്നതും തന്നെ കേട്ടാ. എന്റെ ഒരു വിശ്വാസം
അത് വസുദേവ് അറിയാതെ അൺമ്യൂട്ട് ആയി പോയതാണ്. അത് മ്യൂട്ട് ചെയ്തു.
എന്തെങ്കിലും ചെയ്യേ. അവള് വിചാരിക്കുന്ന പോലെ അവളെ സ്നേഹിക്കണം.
അഡ്മിന് മ്യൂട്ട് ചെയ്യാൻ പറ്റുമല്ലോ.
നടക്കുമ്പോ ഒരു ഗ്ലാസ് വെള്ളം എടുത്ത് തരുമോന്നാണ് നമ്മൾ ആഗ്രഹിക്കുന്നത്.
Yeah, host, please mute it.
മ്യൂട്ട് ചെയ്തു. യെസ്, ആക്ച്വലി നമുക്ക് ഗ്രീൻ ബിൽഡിംഗ് റേറ്റിംഗ് സിസ്റ്റംസ്, നമുക്ക് ഡിഫറെന്റ് ബിൽഡിംഗ്സ് വി ക്യാൻ കമ്പയർ ആൻഡ് വി ക്യാൻ evaluate and give different ratings, അല്ലേ? Like we know the accordingly, this tool also under process. We need to develop it as a rating tool. That's what we are doing.
Okay.
So this is
if so we can incorporate, I understand. അല്ലേ? അപ്പോൾ അതിനൊരു നമ്മളൊരു ലാർജർ ഫോറത്തിൽ ഇതിനെ ഒന്ന് വർക്ക്ഔട്ട് ചെയ്യിപ്പിച്ചാലേ നമുക്ക് ആ ഒരു ലെവലിലേക്ക് പറ്റൂ.
We can adopt it. I was just presenting the concepts.
Got it. Yeah, fine, ma'am. The audience, please. This is an open forum. Please ask some questions so that new things we are learning.
Actually, the main concept is usually people will get confused with green buildings and sustainable buildings. That's what we need to popularize. All green buildings are not sustainable, but all sustainable buildings are green buildings. In green buildings, we are focusing only on environmental aspect, but sustainability is far more than this. We have to consider other three aspects also.
Yeah, got it. This is a new way of there is in this scenario, it is actually a new thing that we are learning, like how to expand our way of thinking. Because in the construction itself we are taking many measures, right?
Yes.
Normally it will be all the sustainable factors will be considered while in the design of the material, choose of materials we will be taking care.
Starting from the planning stage.
Yeah, but this is extending from the planning stage, and in every course we are having certain aspects to be measured.
Yes. During planning, designing, then construction.
Exactly. That's actually in a total we are getting.
Yes, cradle to cradle concept. We'll say that it's cradle to cradle. Yeah. Earlier, all the discussions were about cradle to grave concepts, but now it is extended. Circular economy. Usually, we say circular economy.
Yeah.
It's somewhat similar to that. Yes.
But adaptation to this technology, actually, many discussions, elaborate. So it has to be convinced. Actually, that is where
Ah.
we are lacking. Anyhow, probably in due course it will be coming. Let us wait. Okay,
Mhm.
ma'am. Okay. Thank you
Ah,
for your deliberation, ma'am.
thank you. Thank you.
What about others, please? Students also is there. You may please ask some questions. It's a new area that we are discussing.
What were the other topics during the discussion in other sessions?
Actually, first one was all about the title elaboration. Like Smita ma'am was about title elaboration actually.
Mm.
All the key aspects related to that keyword of the resilience, no, that
Mm.
was her deliberation. And the evening we had something like each and every materials, how we can in a total how we can go ahead with all sorts of this smart materials, usage of smart materials, usage of processes like monitoring the system. All those things was discussed in the first day itself.
Mhm.
Yesterday's session was concentrated on safety aspects and
Okay.
how safety as well as this thing is there is your sustainability is related to and is relation with SDGs. SDG 8 we were connecting. Sir was trying to connecting that, and then came about durability aspects like something uh, durability is one way of having continuity of usage, like there
Mm.
is resilience part, durability comes in a greater issue, right? So that was the discussions that happened. And then yesterday evening discussion was a unique, like something like simple example what I could recall it very fast is we always consider paper glass as the sustainable material,
Mm.
right? Because it's not using any plastic.
Mhm.
But ma'am was suggesting like use a material which could be reused for many times. Like
Mm.
in olden days we were using steel glasses, right?
Mm.
So that glasses we are sterilizing it, we are putting it in warm water, we are washing it, we are using for several times before it is getting recycled or reused. But paper glass is not at all a sustainable factor because on that purview it is sustainable, but beyond that it is not sustainable because it is again getting recycled.
Mhm.
So in that aspect, one discussion was there. Today morning, it was all about environmental impact assessment,
Mm.
uh, and it's actually a sort of like a procedural method, right? It's a documentation way of how to go ahead with a project. So that was the discussion in the morning, ma'am. So
Okay.
this is what all these 3 days we were concentrating about. And from your side, it is all about construction. There is sustainable construction. Normally, sustainable materials we have discussed. Sustainable construction part in a total we are discussing from you, ma'am. We are listening from you.
Okay. Okay.
This
Nice.
is what we had, ma'am. You can also throw some light on some of the concern like this, ma'am.
Yeah, yeah. This also during your explanation, I heard many of the times you were repeating that word sustainable. That's what we
Yeah,
do all the time. But actually, we are not focusing on sustainability. There, we are only talking about green technology.
exactly, exactly.
Because there the focus is only on environmental aspects. Actually, sustainability is more than that. We need to think about, then only we can call it sustainable. That's the
Mm-mm.
reason that paper glass, why it is not sustainable, and this the conventional way we were using steel glasses. Because if we take the people aspect, they prefer the steel glasses.
Yeah. But another one
With
example
respect
that
to
is,
cost, also you can think how many times we will be able to use this
yeah,
steel glasses.
steel glasses.
Yeah,
Yeah,
so that is related to economy aspects. Then we
economics.
need, yeah, technology we can see with respect to the purpose of this particular alternative. Is it the
Yeah, yeah,
same? Yeah, it will serve, but only for single time, the other one for many times. So
yeah.
we can
And,
compare it.
and another one more aspect that ma'am was saying all about is, we are fond of using mineral admixtures. Many of the times we are fond of using mineral admixtures as a replacement for many materials. But
Mm-hmm.
production of this mineral admixtures, for example, fly ash, we have to burn coal or
Mm.
So that is not sustainable because an embedded energy over there is more, because we are utilizing energy for burning it to make it into fly ash and then to utilize it in the for this green technology actually. Not
It's not,
sustainable, green
yeah,
technology. So
that case it's not sustainable, but if we are
yeah,
getting fly ash as a byproduct, then it would be good.
yeah.
But
For
if
that,
you,
if you could consider it is it
ah,
is useless. It is does not serve
yeah,
the purpose.
yes. Yes, thank you,
So
Vasudev. Thank you all.
thank you, ma'am. What
So
about
thank you,
others?
ma'am.
Any more questions? Yeah,
Yeah, someone
Ashmi,
raised the hand, want to ask some
Ashmi.
questions.
She just left. Okay, ma'am.
Okay, thank you.
Thank you, ma'am. Yeah. Hello?
Can I leave the session?
No, 1 minute, ma'am. Any other questions or
I
organizers,
heard,
please?
I heard one voice.
Yeah. Shreya is there? Sahi, ma'am?
Sir,
Yeah. Wind up wind up ma'am.
yes, sir.
Yeah.
Thank you, ma'am.
Thank you.
Thank you, ma'am, for that innovative talk. We are very grateful for you to taking time off from your busy schedule to attend this workshop, ma'am. Thank you so much for coming.
Yes, thank you very
Thank
much.
you.
Thank you. I would like to express my gratitude to all of you for giving me this opportunity. Thank you all.
Thank
Thanks.
you, ma'am, from our side also, ma'am. Thank you.